Hi, it's Mrs. Clark. Welcome to our first lesson in Unit 1, Characteristics of Numbers. Before we get started, I want you to make sure that you're ready. Do you have your math notebook and any notes that you need for this video? And are you focused? Do I have your full attention? If so, let's get started. Today, we're going to look at multiples and factors, and we're going to explore factor trees and how they help us. By the end of today's video, you will be able to identify and describe a number's factors and its multiples, and you will be able to create a factor tree. So let's start with multiples. A multiple of a number is the product or answer of your number when it's multiplied. For example, if I'm trying to find the multiples of the number 5, I would start at 1 and just multiply. You can also think of this as just skip counting. Start at 5 and skip count by 5s, and all of those numbers you say will be the multiples of the number 5. So if I look further at the number 5, on the board you can see I started with some multiplication sentences from my multiplication table. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, and I could keep going on and on and on. All of the numbers that are highlighted, all of the answers, are considered the multiples of the number 5. Can you pause the video and think of the first 5 multiples for the number 4? Remember, it's just skip counting. Another way to remember multiples is to think about the multiple monster. Multiplication, multiple monster. He makes numbers bigger by multiplying them. Remember, finding multiples is just skip counting. And multiples can go on forever. They have no end. I could skip count by the number 2 forever, and I would find as many multiples of the number 2 as I wanted. What about factors? A factor is a number that are multiplied together in a multiplication problem. For example, if I'm trying to find all the factors of the number 9, I would have to find all of the multiplication sentences and the numbers I could multiply together to get an answer of 9. Let's look at 9 further. There are 3 number sentences I could multiply together to get the answer of 9. 1 times 9 is 9, 3 times 3 is 9, and 9 times 1 is 9. And you notice the first and last number sentence are basically the same sentence, just reversed. So I highlighted in yellow the numbers that are the factors of 9. 9 has 3 factors, 1, 3, and 9. Can you pause the video and think of the factors for the number 6? To remember factors, we can think about the factor ninja. He chops up numbers and makes them smaller. So remember that factors are the smaller numbers that are multiplied together to get your answer. Factors do have an end point. Unlike multiples that can go on forever, factors have a start and end point. There's a set number of factors for every number. So for the number 10, it only has 4 factors, 1, 2, 5, and 10. Those are the only whole numbers I can multiply together to get 10 as an answer. Whereas if I were finding the multiples of the number 10, that would go on forever because I could just skip count by 10s forever. What about factor rainbows? I like these because they can be a helpful visual way to keep your numbers organized when finding factors so you don't forget any. Let's try this with the number 24. So you can see on my rainbow that I have 4 arches. If I start with a red arch, it connects 2 numbers, 1 and 24. And I can use the numbers 1 and 24 in a multiplication sentence to give me an answer. 1 times 24 is 24, and vice versa. 24 times 1 is 24. The orange archway gives me the numbers 2 and 12, and I could reverse those and multiply them the other way. 2 times 12 and 12 times 2 both give me an answer of 24. The yellow archway is 3 and 8. 3 times 8, 8 times 3, both equal 24. And finally, my green archway, 4 times 6, 6 times 4, equal 24. So now I can see all of the factors of the number 24 in a nice visual way so I don't get them confused or miss one. Finally, let's look at factor trees. A factor tree can be used and it could be useful in helping you find the prime factorization of a number. Prime factorization is just a fancy way of saying that we're trying to find the prime factors of a given number. So let's try this with the number 12. How can I multiply 2 numbers together to get 12 as an answer? The first thing that comes to mind is 2 and 6. I can do 2 times 6, and that equals 12. Now, if I want to keep going, I look at the number 2. Can I break down the number 2 any further? No, because 2 is already a prime number. It only has 2 factors, 1 and 2. I could move over to number 6. I know there's another way to make 6. It's 2 and 3. So I would list those numbers underneath the 6. And now I'm left with 2, 2, and 3. And I can't break down those numbers anymore. They are as small as I can get. They're all prime. So now I would circle the prime numbers I have left, 2, 2, and 3. And that's it. If I wanted to see if I did it correctly, I could check my work by multiplying. I could start with multiplying 2 times 2, which would give me an answer of 4, and then multiply my 4 by my remaining 3 and get 12. I did my factor tree correctly. Can you pause the video and see if you can construct a factor tree for the number 18? All right, guys, that's it for today. Today, we explored factors and multiples. We looked at factor rainbows and learned how to construct a factor tree. I'll see you in the next video.